What is up, pre-calculus? Welcome to E-Day 2024, or I guess I should say E-Day number 1, 2024. This is me. It is 7:33 in the morning. That's right, I've already done my workout. Drinking my coffee here in my classroom, making this video just for you. Hey, how are you going to get your points today? Here's how you're going to get your points today. You're going to write down everything that I write down, take a picture of it, and then email it to me. Hey, what if I don't have enough technology to do that? What if the video is not working? I'll still take it first thing in the morning. That's fine. Okay, let's get this done in less than 10 minutes. Are you ready? Here we go. This is 5.3. We are going to have a quiz coming up relatively soon. But this is 5.3, and it's called circular motion. 5.3, circular motion. Circular motion. So hopefully you have a piece of paper. If not, like, write it on the back of something. You know, it's all good. Hey, there's two types of circular motion, and here they are. One of them is called linear, and the other one is called angular. And they're exactly what they sound like. Linear velocity or linear motion is like when a thing's like your car is going forward. Okay, that's linear motion. Angular motion is like your tire spinning. Okay, so it's spinning around. That's angular. And linear would be like when the tire hits the ground and it goes straight. Okay, there's two equations. This one is V equals S over T for linear. And all that is, remember we learned last week that S is arc length. Let's call it S. And then T is time. Okay, so that's cool. And then the other one over here for angular, we're going to call that dubs or W. It's actually omega, but whatever. And we're going to call it theta over T. And theta is just the central angle over time. Central angle over time. Central angle over time. So let's do this. Okay, what is the one big thing that you need to remember? You need to remember this. Write this down also. 360 degrees, you know, that's a circle, but we don't call it a circle. We call it one revolution. But as we learn, a lot of equations, including these, use radians. So, and we also learned that one revolution is 2 pi rad. 2 pi radian. I know my handwriting's looking awesome. You guys can pause it, rewind this video, listen to it again. But this is OMG, the important part right there. Oh my goodness. 360 degrees is one revolution, and that's 2 pi radian. We're going to be doing some conversions today, no big deal. Okay, that's cool. Are you ready? Let's do 2 examples, and let's be very happy about that. Write these down. I think you're going to understand them. Man, I hope you're going to understand them. Here we go. Okay, let's say you got a tire. Oh, Let's say you have a tire. I'm tired. No, a bicycle tire, a car tire. Let's say you have a tire, and it has a 14-inch radius. Oh, I gotta think about that. 14-inch radius. Okay, okay, it's okay. Um, and it's rotating, so spinning at 125 revolutions per minute, aka 125 RPM. Okay. Let's find the linear speed. Find linear speed. Well, wait a second. We know that linear speed, V, is S over T. But we got to figure out S first. Oh, 2 pi r theta. And from last week, S equals 2 pi r theta. Do you remember that? 2 pi r theta. Okay, let's do it. So let's figure out S first. Well, S would be 2 pi r, which was 14 inches, and theta is 125 revolutions per minute. Oh, brother. Oh, I did not mean to do that. Oh, boy. Let's move you back up. There you go, right where you belong. Okay, if I multiply all that together, it's going to be, oh gosh, inches, revolutions, minutes. My goodness. So S is going to be what we have to find the arc length. By golly, I think we can just call this 3,500 pi inches. Woo! That is the conversion needed because 2 pi radian per 1 revolution. Oh, okay. So that made the revolution go away over there. That's what this was. Okay. So then inches per minute, but we don't care about that. We just want the length. There we go. And now I can figure out V. It's just going to be 3,500 pi, and that's in inches per 1 minute, because it said revolutions per minute. And then that's going to be, if I multiply by 3.14, 10,995.6 inches per minute. Cool. Okay, so that's the linear speed of that bicycle tire. You think that's a really big number? Weird, but let's pretend it was a bicycle tire. You've gone 11,000 inches each minute. So you could, that's, not much. We could convert that to feet per minute, and then you would say, oh, that's not much, just divide it by 12. And then we could actually convert it to miles per hour if we wanted to. All right, same example. So maybe this, we could have called that 2 pi radians per revolution. per 1 revolution. Yeah, I think that's probably because then that would make the revolution cancel out. Okay, let's do the next one. Oh, same thing. 14-inch radius, 125 revolution per minute. There we go. Same thing. Let's now figure out the angular speed. Find its angular speed. Handwriting's looking sweet. Angular speed in radians per minute. Well, that is W equals theta over T. So I got to figure out theta first, right? So theta is going to be 125 revolutions times 2 pi for radians per 1 revolution. And then theta is going to be 250 pi. And that's in radians. The revolutions canceled out. That's probably over here on this green problem where I should have written radians over revolution. Okay, and now we got to find the angular velocity. So it's just going to be 250 pi per 1 minute, which is 785.4 radian per minute. Okay, so now what do? Here's all you're going to do. You're going to take that piece of paper that you wrote these very lame notes on, and you're just going to take a picture of it and then email it to me. Email me a pic of your notes with name on it. Okay, so your name has to be written on the notes also. That's proof that we at least started our notes, 5.3 notes. Believe me, I am staring at 1, 2, 3, 4, 5, 6, 7 more examples that we have to do on Wednesday. So yikes, right? This isn't the coolest stuff, but I think after about 3 more examples, you guys will catch on. All right, but for right now, you just need to turn that in, email a pic of your notes with your name on it to me. And if you don't have access to a camera or whatever, right when you walk into class tomorrow, you could just show me your notes and that'll be fine also. You'll still get the points that way, just, you know, daily participation points. If you are listening to this with the audio on, and if you don't share this with other people, if you write the number 13 underneath your name, I will give you a point of extra credit, but that is going to go away if I hear anybody asking before class, did you put a 13 underneath your name? Just curious to see how many people are listening instead of just watching. Okay, with that, I say to you, good day.